Okay, equations of parallel lines. Generally, what ends up happening when we're finding the equation of a parallel line is I'm given an equation, in this case y equals 2/3 x minus 4. I am then given, usually I want to find a line that's parallel, passing through a point. And let's say in this case it's the line passing through the point 6, 1. Okay. I'm sorry, let's leave this as 6, 1. Okay. In this particular case, what we know about parallel lines is that they have the same slope. And the reason being, when I think about parallel lines, if I have this line, and I want to find the line parallel to it, you'll notice they have the same steepness. They're just moved around a little bit, okay? And that moving around a little bit causes them to have a different y-intercept. Okay. So in this particular problem, anytime I'm dealing with parallel lines or perpendicular lines, anytime a value is given, I'm going to take that slope. If it's a parallel line, it's going to be the same slope. So I have a slope of 2/3. I'm given the slope, I'm given a point, so then I find an equation of the line. So in this case, it's y minus 1 is going to equal the slope of 2/3 times x minus 6. So if I go through and solve, I have y minus 1 is equal to 2/3 x minus 4. I'm going to add 1 to both sides, so I have y is going to equal 2/3 x minus 3. And if I look at this new equation and look at the equation I had up here, you'll notice the slope is the same, but the y-intercept is going to be different. So these two lines will be parallel because of the fact that they have the same slope. When I look to equations of perpendicular lines, it's going to be something similar, that the slope is going to be the opposite reciprocal. What that means is if the slope of the original line is 2/3, the slope of the line perpendicular to it, which is sort of that upside down T, is going to be the reciprocal, which means I switch it and I switch the sign. And the reason I switch the sign is if I have this being a line, if I want to switch it, okay, it's obviously going to switch from a positive value to a negative value, and the relationship, the difference is dealing with the fact that it's a reciprocal. So how this manifests itself is if I have a slope of an equation of y equals 2/3 x minus 4 like I did before. I'm going to still pull the slope from here, but in this case the perpendicular slope would be the opposite reciprocal. And let's say I take the same point, that it passes through the point 6, 1. I'm still going to set it up the same way, of y minus 1 is equal to, now I need to use the perpendicular slope times x minus 6. So in this case, y minus 1 is going to equal -3/2 x plus, in this case it would be plus 9. I add 1, y is equal to -3/2 x plus 10. Okay, and these two will be perpendicular because of the opposite reciprocal slopes. Now, for this one, you may possibly end up with the same y-intercept. It just would happen that if that's the case, then the intersection would happen to be the y-intercept. It rarely happens, but it can happen. With slope, with parallel lines, if they have the same slope, so the y-intercept is going to be the same line, which kind of defeats the purpose. It's this exact line as opposed to being a parallel line, really. So just know that perpendicular lines, you're looking for an opposite reciprocal. Parallel lines, the same slope. Okay? And that's pretty much about it.